and variance. This is a very useful when you learn about the concepts of machine learning project or underfitting, overfitting. That's a concept are very important when you go through with the bias and variance. So first, understand what is the bias. Bias, understand in simple term. Basically, that's the we have data set. Okay, and this is simple data point. In that particular case, that's the actual point. Actual point is the predicted point, right? This is the predicted point. So in that particular case, what happened? This is the actual point. Though basically this is the error between actual point and predicted point. So we consider this the error is nothing but bias, right? And similarly, when you go with the high bias and the low bias as well, and how the high bias affected the our model and low bias how they are affected in a model and how to handle them or how to work on them, that we will see in that particular video. So first, you need to understand about what is the bias. This is the error difference between the predicted point and actual point. Okay. High bias. High bias it means we understand concepts. Okay. So that's the data points that we have. Okay. Data point that we have, and simply we are a predicted point. This is a predicted point, right? This is your predicted point. So in a high bias, the error the error between the both of file is too large, right? Is a high bias basically condition. It means that's predicted point not capture all the data points in a high bias condition, right? This is simple concept. You see that the data points are far away from the that particular actual predicted point. So this is a high variance, high bias condition, and this is a this applies the underfit. Okay, this is the underfitting when the model is a high bias. So in that particular case, the model is a underfitted. It means the predicted value and actual value are not not to match or it's not to capture all the data points, right? And similarly, okay, this is the pointer done, and this is the make a strong assumption, assuming a linear relation. So when it's non-linear, okay. And what is the effect? It's a high train error, right? High train error, high test error. In that particular case is a high training error when you training a model when we training model. So basically, this is a high error, right? Is when we calculate the accuracy. So accuracy too high. Similarly, is a high test error as well. So when it something like that's your the test point that will be anywhere. So in both of case, training and test in both case, the error will be too high. Similarly, when we go with low bias is good. Okay, unless we have a and that's something like you have data point. Okay, and simply we draw a line, and you will see that they also not make a that much error, right? The multiple data points. Okay, that's a multiple. That's not make a that much error. So this is basically the low bias. Low bias. Basically, in low bias condition, the model is complex enough to capture the pattern in data. The for low bias, we need to complex data, right? We want to complex data. Low bias is the assumption are taken to target function. In this case, the model will closely match the training data set, right? This closely match the training data set, which means the predicted point and actual point is not a too much error, right? Too much error carry. That is simple concept. In the feed the training data well, it feed the training data well and make the few assumptions about the data. It becomes a low training error, right? And contrarily, And basically, when the model are low bias and low variance, basically it's is a generalized model that we want. Okay, generalized generalization model that we want. That we want. I think for the and similarly we understand about some concepts. First, we understand, you know about what is the variance, sorry, bias, high variance, low variance. Similarly, we are going with how to reduce the high bias, right? Way, okay, sorry, way to reduce high bias. Way to reduce the high bias. Okay. So first is a uh, complex model. Right? We need a complex model. Example is the decision tree. Uh, Decision tree, right? Decision tree and the pattern is more complex, right? Second way to reduce high bias is a add a more feature. We want to add more feature, add a more feature. In UC, when you learn about simple linear regression, they carry the high variance because the model is too simple as well, and that don't have that much number of features, right? And you third is a regular. We all this concept of understand about what is the regularization and overfitting, how to deal with it. So your third is the regularization, and regularization also is the yellow one. And yeah, this is the two types of regularization we apply in a model to understand the concept and reducing the high bias. Okay, so this is the bias condition. So you will see in that particular video. This is a high bias. So that's the actual point. That's the predicted. That's the actual point. That's the predicted point. And this the model is not capture all the data point. And this is a low variance, right? This is a predicted point captures all the data point. That's the simple concept you will see in that particular video. Similarly, one more concept that we will understand in that particular video. That is the variance. So variance. Variance is basically you try to understand. Variance is a speed of data. Speed of data. How to the speed or data in a data set from the mean position, right? In that particular way, how the data is split, how the data are split. That's the data split basically is the variance. Okay, this one, this is the variance. So for the variance concept, the first we going with a high variance and low variance. Okay, in high variance case, is the model is a in high variance case. Okay, for high variance, in high variance case, model is too sensitive to the model is too sensitive to the change in training data, right? If the model is too sensitive, model is too sensitive to in a training data. What it's mean? Okay, what it's mean? We understand some same we understand with the graph. Okay, So that's we have a graph, and that's we have something like data points. Okay. So in that particular case, what happening? The model will capture all the trying to capture the all the data points, something like that, right? And when new pointer come here, something like that. So that's make me build too much error, and this create a overfitting condition. Okay, overfitting condition. This create a overfitting condition. So first, the model is the central to the data. When they basically either the model when you training a model, the model is a basically memorize data, right? Memorize the data. So model is a memorize the data. So for that, when the new unseen data came, so is it the error will be increases too fastly. Okay, and similarly when you talk about the low variance, so in that same particular case, the model will be generalized and that's something like that. Okay, and that particular case they carry the all data points are same. Okay, all data points same, and in that particular case, the training error and text error are both are equal. Both are equal. So I hope